This is my workbench.
The issue is it's just pretty dark.
Let's do something about it and try to lighten this whole situation up.
Using scrap wood from some bed frame slats, a few skateboard bearings, a few 3D printed parts, and an old smart light strip I have lying around, I want to make a secret transforming workbench task light thing. I remember when I was a kid, I'd crawl under couches or like a reclining chair. Anything that had kind of like a, moving legs that would pop out. And I would always be amazed by how many different moving parts there were. I always wondered how people could figure out and just sort of imagine how these like interlocking mechanisms needed to be designed to get the leg of the chair to come out and unfold and move up and slide out. It was always so complex to me. Now, I'm sure there's a better system to accomplish that versus what I've figured out here using a whiteboard and a piece of string to measure length, but I don't know the exact measurements we're looking for, but I feel like if we can get close enough, we'll be able to use trial and error. Wood's pretty forgiving, right? Tell that to the forest. So I just made a little mark with my tape measure here, and then I'm gonna use my handy dandy thing called it's called a speed square. Sometimes it's called a rafter square. I've never actually used it for rafter purposes, but from what I understand, if you've ever been in the attic of someone's home, you've seen all of those pieces of wood that come together at angles to make the shape of the roof. A rafter square is how people are able to measure and make the cuts necessary. You can sort of hang a piece of string with a weight on the end. I think it's called like a plumb while bracing this up against a piece of wood, and the resultant angle tells you something about something else. So I am just using it to make straight lines. Thankfully, because this is somebody's old bed frame, I'm actually using the holes in the wood here that were used for these little plastic plugs. I imagine these were to help like the bed slats actually fit into the bed frame, but they're pretty consistently right in the center. So I think I can draw a straight line between them, and that'll probably be close enough to splitting it down the middle. It's gonna be kind of difficult to guide the circular saw on a straight path. What I think I'll probably end up doing is clamping whatever uncut piece of wood I have to the piece of wood that I'm trying to cut. Then I can just take the circular saw and just focus on pressing against that. But we'll see how it goes, because all of our pieces of wood are pretty skinny, so it might be hard to hold things steady. Guess we'll find out. Let's go outside. Looks like the strips that we're trying to cut are too skinny for me to fit another piece of wood as like a guide. So we're gonna use some other scrap wood I have out here and cut on that. Pascal loves power tools. Ain't that right, buddy? If we turn this knob here, we're able to actually move this guide thing, changing how deep the saw blade is gonna cut and whenever we're cutting. I'm gonna look at one of the pieces of wood that we're trying to cut here, and I can kind of make sure that the saw blade will cut through, but not much farther. Does that look good to you? Here's the piece we're cutting. Here's the piece we're not cutting. Now, if this works, I should be able just to focus on getting this guide up against the wood, and it should cut. Sometimes you need to make some fine adjustments. All right, I think we're ready to cut. Success. I think that's close, so we'll clamp it up. I don't expect my wood to be straight, but this is pretty warped.
Can you see that?
Circular saws, like the one I'm using right now, are able to tilt the blade. I think it's to like make better joints. But since this wood is like really curved, I'm wondering if I can turn the blade a bit so that it cuts straight despite the curvy wood. Seems like a bad idea, but I think I'm gonna do it anyways. Can you get prescription safety goggles? That would be something I should look into. Oh, I almost cut right through the chair. I think these slats were originally sanded to some extent at the factory, but now that we cut all these in half, they all have an exposed edge that I'm absolutely gonna get a splinter from at some point. This wood is probably treated with some kind of chemical, so it's probably not a great idea to sand it and inhale whatever the hell is coming off of that. I think the plan is to clamp all of these together and sand all of them in one pass, because I think I can hold my breath. You are covered in sawdust. I can't wait to have a garage where I can do all of this in a more controlled environment. Also, half the time I'm out here, I'm getting like seriously judged by my neighbor's cats. They're usually in that window, but I don't think they're out today. Now comes my least favorite part of this whole thing, which is dealing with the LED strips. We're gonna try to solder these. It's never gone well for me before, but our LED strip is about 4 times longer than the board, so I'm gonna have to solder somewhere between 3 and 4 times is my best guess. Do you think I'm supposed to cut on the dotted line with the scissor icon, or in the direction that that arrow is pointing? I'm gonna take a educated guess and say that we're probably supposed to cut not on the dotted line, but on the metal contacts. It's gonna be easier to solder if I do that. All right, okay, we're doing it. This feels like a risky haircut. I'm pretty sure this is what I wanna do, but I won't know for sure until it's over. And also, I probably shouldn't be the one holding the scissors. How do y'all feel about LinkedIn? I feel like LinkedIn today functions a lot like the popular cliques in middle school / high school. Like, I don't necessarily want to be part of your club, but I feel like things would probably go significantly better for me if I were. How am I going to attach these LED strips? There's also this little like control brick for the LEDs. I have no idea where this is going to go and not be a total eyesore. But that sounds like a problem for me next week. It's hot in here. Me and Pascal have to figure out how we're going to attach the strip to the board here. I could like 3D print some brackets, but I'm thinking since this will hopefully be semi-permanent, this whole project might warrant the use of some stronger adhesives. I realize I've strayed pretty far from the whole mission of this, which is to get myself a better light so that I'm able to work on my eyeball project here, but little progress update. How cool is that? Look at that guy. Got some servos. This is my first time ever working with servo motors, which feels kind of insane to say because I feel like robotics have always been interesting to me. And I guess I never got the permission I thought I needed to just start buying electronics for purposes other than school. Does that make any sense? Like I'd spend like $200 on my graphing calculator because that's what my professor told me to do. But it felt so difficult for me to justify spending like $100 on electronic materials that I could learn from and play with for like the next 5 years. All of the electronics that you see here cost how much, Pascal? What do we pay for this? Like 40 bucks total? Better late than never. So I went ahead and made this little test bracket here. The goal is that the skateboard bearings are gonna fit in these 2 holes. And then, using some combination of witchcraft and engineering, our light bar will go from here, lift, and pivot out and over. Now we've got our lights, and when we're done, we can just stash it away like that. All right, onwards. It's currently held together by duct tape, but that's okay, aren't we all? But we have a semi-functioning prototype. If you see here, oh shit, you can see, comes out. Pretty good. I think we've definitely reached the zone where it probably would have been a better use of time and money just to buy a solution to this problem instead of working too hard to do it yourself, but that's kind of what life's all about. What do you think, buddy? Anywho, once Pascal decides that cuddle time is over, Pascal and I still have to figure out how this light's gonna turn off and on. In an ideal scenario, the light would turn on automatically whenever you pull it out to use it. I imagine I'm gonna wanna use what's called a momentary switch, which is basically a switch that's only really doing anything or changing state when you're interacting with it. Versus something like a toggle switch or a slider switch, those are switches that have basically states that you can switch between. The switch is still doing something even after you take your hand off it. What I'm thinking here is a momentary switch. That's where the next layer of switch trouble comes in, because momentary switches are typically classified into two different genres, normally closed and normally open switches. If you make a little circuit with a normally open momentary switch, by default, that circuit's gonna be open. An open switch with the LED light strip basically means no light. Once you take an action and you depress that momentary switch, the circuit is completed and voila, we have light. The other option, which is what I think I'm after, is a normally closed switch. I believe if we rig up a normally closed momentary switch, then the strip will by default be on until it's stowed away and makes connection with that button. I'm being a little bit willfully ignorant of some possible cons with this design. If I don't stow the light strip away properly, maybe that switch won't have made proper contact and the light strip will be on all night, wasting power. I'm not exactly sure what to do about this, and so I think I'm just gonna ignore it for now. All right, the plot thickens. Your average RGB or reg glue usually has one LED, kind of made up of 3 tiny LEDs. Makes up all of those colors that you can pick on your app or whatever. This is kind of a fancier light strip, I'm realizing. I think there's a term for it, it's like RGB IW. So you can see here, there's kind of like one big white diode, and then there's also 4 other LEDs. So when this light strip actually lights up, it's using some combination of those to achieve whatever color that you specify. It produces a much more natural light when you're trying to get something in like the white, warm white, cool white range. But the other consequence of this is that instead of having to solder like 3 or 4 wires, I'm counting 7 opportunities for me to mess this up. If you'd like to stick around and see how badly I mess up the soldering, I hope you do. Getting late, I got work in the morning, so we're gonna call it here. Vlog number 1 complete.